x times positive 4, so that would be a plus 4x. And then the inner terms would be the positive 5 times x, bless you, so plus 5x. And then the last terms would be positive 5 times positive 4, so plus 20. And then we can combine the middle terms, the 4x and 5x combine to be 9x, so x squared plus 9x plus 20. So that's just the review of multiplying. So why I'm reviewing this with you, one way is for you to see, now you're going to be starting with the trinomials such as x squared plus 9x plus 20. And when you're asked to factor, you are doing the reverse of FOILing, so your answer should be something in the form of x plus 5 times x plus 4. So it's going to be working backwards. But I also want to show you, I realized depending on when and then how you learned Algebra 1. If you were in the classroom and depending on who you had as the teacher, and then if you were in Alex, it might have been different. I show factoring. One way to organize factoring is to set up a diamond problem. So this is where when you're looking at a trinomial, we'll put what number we're trying to multiply to on the top, what number we're trying to add to on the bottom, and then the two values we got go on the sides. So I just want to show you with this how you can go from the trinomial to the factored form. And this is specific to the a value, because this is in the form ax squared plus bx plus c. The a value here is 1. So that does make a difference. We will go through examples where the a value is not 1. But when the a value is 1, when you're looking at a trinomial, you're looking for two numbers or two factors that multiply to your c value, so in this case multiply to 20, and then add to your b value, which is positive 9. And then two numbers that multiply to 20 and add to 9 would be 5 and 4. And if you look at the factored form, notice the 5 and the 4 in the factored form. It factors to x plus 5 times x plus 4. So if you set up a diamond problem, then you get the two numbers you need to go into that factored form. Okay, so we'll work through examples using those diamond problems. And again, it's a little different when your a value is not 1. So first we're looking at factoring trinomials of the form x squared plus bx plus c. So that a value, the number in front of the x squared, is 1. And then also notice with these two examples, and I have this throughout the lesson, some of the directions say to factor, and then some say to solve. So knowing the difference in how you leave your answers when you're just factoring versus when you're solving an equation. So if we look at number 1, factoring x squared minus 11x plus 30, if we set up the diamond, and do I have to see the diamond on your sheet when I'm correcting factoring problems? No. If you can factor without it, you don't need it. It's just a way to organize it if you need it. So from this trinomial, what number are we trying to multiply to? 30. And we're adding to what number? It should be negative 11 because it's a minus 11. So what two numbers multiply to a positive 30 and add to a negative 11? Lisa? So negative times a negative would be a positive 30, and then they do add to a negative 11. So then the factored form is x minus 5 times x minus 6. And it just says to factor, so that is your answer. How could you check to see if your answer is correct? You could FOIL it. Okay, so foiling this, if you get back to x squared minus 11x plus 30, then you know you have the correct factored form. So any problem I ask you to factor, you can check your answer. Think about that on the quiz on Friday. So then number 2, similar process, but we're solving. So remember, when you're solving an equation by factoring, one side needs to be 0. So if one side is not 0, do that first. In this case, we already have 0 on one side. You factor the other side. So we're going to have to factor this trinomial. And then use the zero product property to solve it. So since we already have 0 on one side, we'll factor the left side. So if we set up our diamond, in this trinomial, what are we multiplying to? -21, and adding to -4. So what numbers multiply to a -21, add to a -4? Yep, -7, and then +3. So when you multiply to a negative, one has to be negative, one has to be positive, and then we're adding to a negative, so we want to make sure that we do get negative when we add them together. No, if you have the opposite order, that's okay. So then, factored, this would be x minus 7 times x plus 3, or x plus 3 times x minus 7. We're not done though. We still have the equation equal to 0. We still have to solve it. So then remember to solve it using the zero product property, I set each factor equal to 0. So either x minus 7 equals 0 or x plus 3 equals 0, and you solve both for x. So the first one, I would add 7 to each side, so x is equal to 7. Or for the second one, subtract 3 from each side, x is -3. And those are the two solutions. So again, when directions say to factor, this is how you leave your answer. When directions say to solve, you are still factoring, but you don't stop there. You go ahead to use the zero product property to get your solutions. Questions on either of those two? Okay, now 3 and 4, these are still factoring trinomials. Except now your a value is not going to be 1. So here a is a value other than 1. So for example, in number 3, our a value is 7. So this does work a little differently. We can still set up a diamond, and in 3 we are just factoring. In the diamond though, we are no longer just multiplying to the c value. So we're not just multiplying to 4. To figure out what you're multiplying to in your diamond, you multiply the a value by the c value. So we're multiplying 7 times 4, meaning we're multiplying to 28. And you now could go back and argue we are still doing that same thing in numbers 1 and 2. When your a value is 1, when you multiply a by c, you're just going to get your c value if the a value is 1. So we are still doing that process. It's just if a is 1, you're just going to have your c value there. And then you are still adding to your b value. So we're still adding to 29. So what numbers multiply to positive 28 and add to positive 29? Grace? 28 and 1. Okay, and I'll make this point now. The diamond is also what tells you if you're able to factor it. Sometimes you're not able to factor, in which case it would just be prime. How you know if you're able to factor it is if you cannot find values that work. So if there were not any values that multiply to 28 and add to 29, then it would be prime. So if that comes up, it could. That is a possibility. Not all of them can be factored. But what I'm going to show you next, if you don't want to write it down, that's fine, because I'm going to show you something that is wrong. This is not the right answer. So do not go from here and do what we did before and say the factored form is x plus 28 times x plus 1. Okay, this is not right. Why is it wrong? How do you know it's wrong? Or if you're thinking right now, I don't know why it's wrong, how could you figure out whether or not it's right, I guess is my question. Allie? It does have to do, you're thinking of the right step though. How do you check if it's right? The 7 isn't there, Lisa. Right, if I go ahead and FOIL this, because I can check it by foiling, I should get back to here if it's right. But when I FOIL this, x times x is x squared. I need a 7, and I don't have a 7x squared. So it doesn't even matter what the rest of this is not right. Okay, so there is a difference when your a value is not 1, you don't just go straight to here. Now, there's really 2 methods you can use to factor this. One method, and however you factor it, it's up to you. I do not care. I just want you to be able to factor it. One method you could use is just literally the guess and check method. Okay, and this is how you could go about guessing and checking, and some of you maybe do this. So I know it's going to be a binomial times a binomial when it's factored. And you have to think the reverse of foiling. So when I FOIL, I need my first terms to multiply to be 7x squared. So you start to think, how would I get 7x squared? Well, to get 7, I have to multiply 7 by 1. And then to get x squared, I need x by x. So the only way I'm going to get 7x squared is if one of my first terms is 7x and the other one is 1x or just x. Because then I would get the 7x squared that I need. And then again, the reverse of FOIL, I would need the last terms to multiply to be 4. When I multiply these two, I need them to multiply to be 4. Now to get 4, I could multiply 4 times 1 or 2 times 2. So I have some options. And then if I have 4 times 1, like if I have 2 by 2, or 2 times 2, both of these would be 2's. But if I have 1 times 4, I then have to figure out where does the 4 and the 1 go. Does the 1 go here and the 4 go here, or the 4 go here and the 1 go here? So that's why it's called guess and check. You literally fill in the numbers and check with FOIL to see if it works. And if it doesn't, you try something else. I personally hate guess and check. Some people are really good guessers. I am not. So usually my first guess isn't right and I get really frustrated with it. So I will show you a method that is not guess and check. But if this works for you, if that's how you factored before and it makes sense, do it. The other way you can factor without having to guess and check, and you could also use this method for the 2 we did above. This is just an easier case when your a value is 1, is to use the diamond we already came up with. So what I'm going to do is I'm going to rewrite this trinomial. I'm going to keep the first and the last terms, but I split my middle term using the 2 values I got in my diamond, the 28 and the 1. So I would have, I'm going to keep the 7x squared. Instead of writing plus 29x, I'm going to write plus 28x plus 1x. And then I'm going to keep the plus 4. So the 28x and the 1x are coming from the 28 and the 1 in the diamond. And I'm splitting the 29, because 28 plus 1 is 29. So I'm allowed to split it. And now I have, rather than a trinomial, I have 4 terms. How do you factor 4 terms? What method do you use when you have 4 terms? This we did last week, Tuesday. What method? I can't hear what you're saying. No? Macy? The 2 and the 2, yes. The grouping method. Okay. There's no guessing involved here when you're grouping. So remember, when you're grouping, you look at the first 2 terms, find the GCF. So what's the GCF of 7x squared and 28x? What do they have in common? They have a 7 and they have an x. So I factor that out of the first 2 terms. When I factor 7x out of those first 2, I'm going to be left with 1x, or just x, plus 28x divided by 7x is 4. And then I do the same thing for the last two. 1x and 4, what's their GCF? 1. Sometimes the GCF is just 1 and it's positive. So I'd put positive 1, so plus 1. And when I divide them both by 1, I'm still going to have 1x or just x plus 4. And with grouping, your two parentheses should be the same. If they're not, perhaps you didn't find the GCFs correctly or didn't factor them out correctly. So since I have the x plus 4s as the same, I take the x plus 4 out. And when I remove the x plus 4s, I'm left with my two GCFs, the 7x plus 1. And you can kind of see if you look over to where I was setting up the guess and check, where I had one of my options was the 7x plus 1 and the x plus 4. But you'd have to, like I said, try it out and see if it works if you're doing the guess and check. This is a way to not have to guess. So whichever way works the best for you. Questions on 3. And if you have the parentheses flipped, that's still fine. All right, so I would like you to do number 4. Just make sure after you factor, this problem does say to solve. So when you factor, you're not done. You still need to then solve the equation like we did for number 2. So go ahead, try number 4. I'll give you a minute before I start walking around. Actually, though, just because I don't want this to take too much time with the diamond, for number 4, what are you trying to multiply to with your diamond? 60, the 3 times 20, and then you're adding to negative 17. Anybody know what two numbers would work? Grace? Negative 12 and negative 5, yes. Okay, so now that that's set up, whether you're guessing and checking or using the grouping method, go ahead and solve that equation by factoring. And help each other out too, but in a minute I'll be walking around. I can answer questions. If you're grouping, you don't need to guess and check.
Like, how would I get, well, yeah, I had a, I thought I could do several different things, and then I but then oh my god, I could have done it that way.
So when if you do the diamond, these numbers have to be. I see. Alright, I know some of you are still looking at it, but double check what you have or what you have so far. Final answer, x is 4 or positive 5/3. Questions on example 4? Okay, and again, guess and check or the other method, whatever works for you, use it. You just have to make sure you understand factoring and make sure you ask questions if you're not understanding something. If we take a look then at 5 and 6 on the back. So these are still trinomials. 7 and 8 are kind of a separate group of examples, but these are a specific type of trinomial. They are perfect square trinomials. Not every trinomial is a perfect square trinomial. And what I want to, I guess, stress for this is perfect square trinomials, knowing the formula is a shortcut. However, you could still factor these the same way we did on the front because they are still trinomials. So you could still do the diamonds. So I'm going to show you how to use the shortcut. If it makes sense, use it. If it doesn't, use the diamond. So looking at number 5, we have x squared plus 16x plus 64. If you recognize that your first and your last terms are perfect squares, you might have a perfect square trinomial. So I know, this is how you check. I know x squared is a perfect square. If I take the square root, it's just x. And then I know 64 is a perfect square. If I take the square root, it's 8. So now to check if it's really a perfect square trinomial, that's what these formulas are trying to show you, is it's either going to be in the form x or a squared plus 2ab plus b squared or a squared minus 2ab plus b squared. So again, this shows that your first and your last terms are perfect squares. And then the plus and the minus, that only matters when you're actually factoring it. In this case, we have plus. But the 2ab is the same. The a and the b are the square roots of your first and your last term. So what this means is to check if this is a perfect square trinomial, I now take my x and my 8, my two square roots, and multiply them together. That's 8x. And if I double that, so if I multiply it by 2, I check to see does it equal my middle term. In this case, it does. And if it does, notice how it factors. So if your middle term is positive, that just means in your factored form you will see plus. If your middle term is negative, in your factored form you will see minus. But this means in factored form, and it comes from my two square roots, my factored form is x plus 8 times x plus 8, or I can write that as x plus 8 quantities squared because they're the same quantity. So either of these two forms would be correct. So it's a shortcut if you notice your first and your last terms are both perfect squares. If you take the square root of each, multiply them, and then double that if it's equal to your middle term, then you can get to your factored form a little quicker. But again, I could still use a diamond. I want to show you that. So if I set up a diamond for this, I would have been multiplying, my a value is just 1, so I'd be multiplying to 64 and adding to 16. my two numbers would have both been 8. So you can see you're still going to get to the same form if you do the diamond. It's just a shortcut if you understand the shortcut. Questions on 5? Okay. 6 is very similar. It's just asking you to solve. So just to save some time here, because I do want to leave at least a little time if you have questions or to work, I want to look at example 7. 7 and 8 are also very similar, so we'll just look at 7 here. 7 and 8 are both trinomials, but notice they look different than the trinomials we factored for the rest of this lesson. They're not ax squared plus bx plus c. We have z's in there. Remember, I haven't talked about it because we haven't had one, but always check for a GCF first. So what do all three of these terms have in common? They all have a 4. What else? They all have a z squared. So if I factor that out first, if I factor out 4z squared, I'm then left with 2x squared minus 1x, or just minus x, and then minus 3. And now if I ignore the GCF, it's still part of my answer. But if I ignore it for now, I have a trinomial that is in the form ax squared plus bx plus c. And now I can try to factor this, or see if it factors. So if I set up a diamond for my new trinomial here, what number would we be trying to multiply to? -6, the 2 times -3, and then adding to what number? -1. And remember, if there's not two numbers that work, then it can't be factored any further. If there are two numbers that work, you can factor it. So are there two numbers that work here? Now, two numbers that multiply to -6 and add to -1. Yep, 2 and -3. +2 and -3. Okay, so again, I'm going to kind of take a shortcut here. You would go ahead and you would factor this the same way we did on the front, and you would make sure your GCF is still in front. Okay, are there questions from there? I just want to make sure we get to number 9 because that one's a little bit different and still leave some time at the end. So from here, again, you're ignoring the GCF. It's just part of your answer. Well, actually, we may have time if I write this out. So from here, either you guess and check, or you can go to splitting the middle term because your a value isn't 1. So I'd keep the 2x squared, and now I use the two values from my diamond, the +2 and -3. So I'd have plus 2x minus 3x, and then I still keep the last term of -3. And then I still have the 4z squared in front. And then this I factor by grouping. We'll go ahead and just finish this one. I think we'll be fine. We'll just skip number 8. So again, the GCF in front just kind of hanging out. That's part of your answer. But what do 2x squared and 2x have in common? 2x. So if I take that out, I'm left with x plus 1. Make sure if you are dividing 2x by itself, it's 1, not 0. And then what do minus 3x minus 3 have in common? What would this GCF be, or what would we take out? A 3, a +3, or a -3? We want, because this is negative, we want to take out a -3. And that way, now minus 3x divided by -3 is +x. Minus 3 divided by -3 is a +1. And our x plus 1s are the same. So this becomes x plus 1 times 2x minus 3. And then I still have the 4z squared, the GCF in front. So that would be the fully factored form. Okay, so you'll see whenever you're asked to factor, sometimes it's multiple factoring methods you're using. Maybe there's a GCF first, and then you're factoring a trinomial, or whatever it might be. Questions on 7? Okay, 8 is very similar to that. It was just an extra example, but the same type of process. So then if we look at number 9, this one is a little different. You can see there's a different goal along with it. So being able to write quadratic equations in standard form if you're given the solutions. So it says write a quadratic equation in standard form with 3/4 and -5 as its roots. Remember, roots is an alternative word for solutions to a quadratic equation. Okay, I'm going to review standard form with you. Standard form for a quadratic equation is ax squared plus bx plus c equals 0. And your a, b, and c all have to be integers, meaning you should not have fractions or decimals in your equation. Okay, so I actually want to look back at example 2 because this is working backwards. You are given one solution is x equals 3/4, and then the other solution is x equals -5. So if you look at what we did in example 2, I will flip back to that if you still need to write stuff down. You are working backwards. So in example 2, we were given an equation in standard form, and we had to find the solutions. So think about this. If you worked backwards, my solutions were 7 and -3. I can then go back into factored form, but notice in factored form, if my solution was +7, that factor is x minus 7. And then if my solution was -3, that factor is x plus 3. So in factored form, the signs are opposite. And then from factored form, I can FOIL to get back to my standard form. So if we go ahead and do that, we have our solutions. So we're going to start out by writing it in factored form. And remember, in factored form, your signs change. So if I have +3/4 as a solution, the factor would be x minus 3/4. And then if I have -5 as a solution, the factor would be x plus 5. So the signs are opposite. And then it's always going to be equal to 0. In the end, your equation should be equal to 0. Any questions on how I got the factored form? Okay, and then you FOIL it to get it into standard form. We do have a fraction, so there's going to be one extra step. So first terms would be x times x, that's x squared. Outer terms, x times 5 would be plus 5x. Inner terms, -3/4 times x would be minus 3/4 x. And then -3/4 times 5, this is like 5/1. So if I multiply the numerators and the denominators, that would be minus 15/4. I still have the equal 0. And I would encourage you to leave these as fractions because now, if standard form cannot have fractions, what would I do to this equation to get rid of the fractions? Multiply everything by the denominator, which is 4. And as long as I do it to everything on both sides, it's still correct. So I would then have 4x squared plus 20x, and then when I multiply 4 by -3/4, the 4's cancel, so minus 3x, and then 4 times 15/4, 4's cancel, so minus 15. And then I just need to combine my two middle terms. 20x and minus 3x is 17x. So altogether, it's 4x squared plus 17x minus 15 equals 0. Okay, you could also, when you have a solution that's a fraction, you could look back. I'll flip back to it if you still need to write stuff down. You could look back even to number 4 when we had 5/3 as an answer, look at how that factor was written, 3x minus 5. Ultimately, it's just checking to see, can you get back to the correct standard form? So, again, there's no worksheet. There is still practice for you to really fully understand this. Odds are in the back, even answers I'll have on the board tomorrow. Any of those problems could be on your homework quiz. Also, make sure you're looking back at what we did last Tuesday for your homework quiz. And then see me if you have questions.